Okay. Hello friends, this is Mandar Datar and today I am explaining you the concept of Jacobian in partial derivatives. So to begin with, let me define two functions of two variables x and y. So let me take u as some function f1 of x and y. So there are two inputs and u is output, and another function is given that is called as v, and that is another function, say f2 of two variables x and y. So now there are two functions u and v, both are separate and both are of inputs x and y. So here we can interlink u and v, because u and v both are depending on x and y, and that linkage can be done by using a concept called as Jacobian. So Jacobian is defined, it is usually denoted by a capital letter J, and it is defined as Jacobian of u upon u comma v with respect to x comma y. The Jacobian is usually a determinant, and if there are two functions of two variables, the Jacobian is a 2 cross 2 determinant, and this determinant you can easily obtain. How to obtain this determinant? You take the first function u, differentiate it partially with respect to x and with respect to y, and write down that as the first row of this matrix. So this first row you can obtain by taking the derivative, partial derivative of u function with respect to x and y. And similarly the second row you can obtain by taking the partial derivative of v with respect to x and with respect to y. So if you simplify this determinant, the value of this determinant is called as the Jacobian. So Jacobian is actually a determinant which link the uv function together with x and y. Okay, so let us take one example for this. Let me take two functions over here. Suppose y is equal to x plus y whole square and v is equal to x upon y. So here I have taken some simple functions of x and y. Let us find out what is Jacobian of uv with respect to xy. So I'll say that J is Jacobian of uv with respect to xy. Here we are using this symbol called as dabba, and this dabba is used because we are calculating partial derivatives. So this is equal to, now let us create the matrix u with respect to x, u with respect to y. So u I am taking with respect to x, u I am taking with respect to y, and similarly v with respect to x and v with respect to y, that will be the second row. Okay. Now let us actually find out what these values are. So now I am differentiating u with respect to x. Now when I am doing this, it's a partial differentiation, so I am keeping y constant. So now you look at this relation. If I want to differentiate this with respect to x keeping y constant, this 2 will come over here and it becomes 2 times x plus y. So in place of ux, now I am writing 2 times x plus y. Now u with respect to y, similarly differentiate u with respect to y keeping x constant, so it is 2 times x plus y. So as usual differentiation we are doing. V with respect to x, now see that x upon y, y is constant, so v with respect to x I have to write 1 upon y, and v with respect to y, now y is in the denominator, so we have to take the derivative of y and it will be minus x upon y square. So now just open this determinant as usual, you have to multiply this minus multiply this, so we are getting minus 2x upon y square into x plus y minus 2 upon y into x plus y. So the value of this is called as the Jacobian of uv with respect to xy. So this is about the Jacobian. Now where this Jacobian is used, so let us see one application of this Jacobian. Suppose I have given two functions. For example, say u is a function say f1 of xy and v is a function f2 of x comma y. So u and v are two different functions given to me. I want to determine whether u and v are related to each other by any relation. So now by inspection this is not possible always. So by Jacobian you can determine this as analytical method. So let us see how to determine this by using Jacobian. What I simply do, I will calculate the Jacobian, that is of uv with respect to xy, and if this Jacobian value turns out to be 0, then I will say that this u and v, they are interlinked or they are related to each other by using a relation, and that relation also we can explicitly find out. Okay, so let me take one example for this. I will take one simple example. Let me take u as tan inverse of x plus tan inverse of y, and v I will take as xy divided by x plus y divided by 1 minus xy. So let us take this example. So I have given two functions u and v, both are functions of x and y. I want to know whether u and v are related to each other or not. Now by inspection this is not directly possible, so let us determine this by using Jacobian. So I will start with finding Jacobian. I will say that Jacobian of uv with respect to xy I will find out, and by given formula it is a determinant. So ux, uy, vx, vy. Okay, let us find out the values of this and substitute here. So we are getting a determinant. Now ux, so it is tan inverse x, so we know the derivative, it is 1 upon 1 plus x square. Uy, it is tan inverse y, we know the derivative, it is 1 upon 1 plus y square. Now to find out the derivative of this with respect to x, we have to apply u upon v rule. So let us find out this. It is 1 minus xy into bracket, derivative of this with respect to x is 1 minus x plus y into derivative of this with respect to x is minus y divided by 1 minus xy whole square. So we are getting this as vx. Similarly vy also we can calculate. So let me find out vy over here. So vy will be 1 minus xy into derivative of x plus y with respect to y is 1 minus x plus y into derivative of this with respect to y is minus x divided by 1 minus xy whole square. So we know that if you find out this product, it is ux into vy. So ux into vy, ux is 1 upon 1 plus x square, so I have to multiply this by 1 upon 1 plus x square, and minus vx into uy, so I have to multiply this with this. So let me simplify this over here. So Jacobian is equal to this plus, sorry, it has to be minus in between, 1 upon 1 plus y square into 1 minus xy minus plus y into x plus y divided by 1 minus xy whole square. So if we simplify this, you can easily see that this out to be 0. Everything is cancelled and it turns out to be 0. So the Jacobian is equal to 0, and that's why we can say that u and v are related to each other. Now how this relation is? So now see that if I take V, or I'll start with U. What is U? U is tan inverse of X plus tan inverse of Y. And we know the formula of tan inverse A plus tan inverse B. It is equal to tan inverse of A plus B divided by 1 minus AB. So it is X plus Y divided by 1 minus XY. And now this is given as V. So we have U is equal to tan inverse of V. So this is the relation between U and V, and this is explicitly found out, but it is also given by the Jacobian's result. Thank you.